So for the AP answer sheet for calculus for AP Calculus BC 2022, me and Kai work on question 5 of the thing where we it seems like we're working on the using our knowledge of volumes using calculus to calculate this, and also area. So the first question it has this on the area of R, which is this region right here. And so we know right away the limit is from 1 to 5. And so now I'm going to set up the equation for A. So it's going to be integral. Give me a moment, I'll fix that. So as you can see, I set up the thing. So it's integral from 1 to 5, 1 of x dx. The reason is 1 of x is because they shown the graph for figure 1 of R is 1 over x. And then using your knowledge, you should know that the integral of 1 over x is natural log of natural absolute value of x. And using that, I got natural log of 5. So that's the area of R. So now what they're asking is region R is the base of a solid. For the solid, at each x, the cross section perpendicular to the x-axis is a rectangle with an area given by xe to the x to the power of x over 5. Find the volume of solid. Typically, in this question, my instinct was to think about like using the like the area of a rectangle, which is base times height. However, they give you the area already, so simply just plug from 1 to 5 and x e to the x over 5 dx. Reason being area, because on a typical conic section that asks about rectangles, they'll give you the height, and so from the height you have to use the height times with the base. In this case would be 1 over x. However, they given you this area, so simply plug in 1 to 5 and the area. And now for this one, it seems like what you need to do is to probably do integration by parts. And so I'm going to show that, but first I'm going to write it out so I can talk through it later. So using this formula, you will find a way to find integration by parts. Firstly, you have to define what's u and v. In this case, it's a bit opposite due to the fact that I kind of like did some opposite, but like instead of putting x as that, I defined it as 1. And as you can see here, it's like this, and the simple integration, and I got 20 e to 1/5, or 20 fifth root e. And that's my final answer. Just typically you would think u prime would be x, but the fact that it's a bit more complicated if you do the other way. So what I did was I switch it instead. It means if you get the answer, you get the answer. So for C now, find the volume of the solid generated when the unbounded region W is revolved about the x-axis. So as you can see here, so that means the W region here is from 3 to infinity. So in this case, would be C would be integral from 3 to infinity from 1 over x squared dx. But remember, we're not finding the area, we're finding the volume. So we have to use the famous pi, and then the inside should be square, because typically this is what people make mistakes. The fact you see x squared, you're like, oh no, remember, and then stuff like that. But you see there's an infinity. This means This what we're going to do now is called improper integrals. So I'm going to set my b as infinity, and I'm going to do pi integral of 3 to b 1 over x to the 4th dx. And so now from here it's just simple integration, trying to integrate 3 to b 1 over x4 dx. So I'm gonna write my answer out and then we'll compare after a few seconds. So here's my final answer after full integration. What I got is negative pi over 3b plus pi over 81. Now we need to evaluate the limits. And so as b approaches infinity, that means this value right here will equal to 0. That means our final answer will be pi over 81. And that is our final answer for the volume of that region, of the unbounded region W right there. It's going to be pi over 81. And that's my final answer. Thank you.